Welcome to Building a Personal AI Assistant. Thank you all for joining us today. I hope you've had a great day at the Stockholm Summit so far. The convergence of generative AI and multimodal large language models is transforming how we build personal assistant devices. And today we want to show you how to harness large language models through Amazon Bedrock to create AI assistants that can understand context, provide meaningful responses on different types of devices. My name is Gunnar Grosch. I am a principal developer advocate at AWS. And this is my colleague, almost colleague, I guess. It's Amazon, and it's Anisha.
Hey, I'm Anisha. I'm a developer advocate at Amazon Devices. And it's basically my job to improve the developer experience for the Amazon App Store, which is what runs on all of our devices like Fire TV and Fire Tablet. So in today's session, we're going to show you how you can leverage AWS services to create innovative AI-driven solutions that can run on any device, like the Fire Tablet, maybe.
So there are three key trends that we are seeing that are shaping the future of AI personal devices. So while wearable tech is now everywhere, we all have smartwatches and smart devices, the current type of assistants are usually not fully utilizing these devices' capabilities. So users are demanding more proactive assistants that understand context rather than just following commands. And most exciting is perhaps how generative AI now is enabling these assistants to anticipate needs by combining multiple types of inputs, from voice to environmental data for a more natural interaction.
Well, today's session is going to start with an overview of the technology and solution architecture. Then comes everyone's favorite part. We're going to build. Do you guys want a demo of what we're going to build? Should we? Should we do a live demo?
Let's do a quick one.
Let's do one. All right, OK. So this is the app that we've built. And it's on my phone, but we're going to take a quick selfie. OK. And then we're going to send it to the LLM to analyze. So hopefully you can hear the response. It's coming back. The Wi-Fi is not the best in here.
A smiling couple on stage,
Thanks
possibly
for
at
a
a
couple.
conference.
Awkward.
We're not a couple. We are two people.
But there we go. Sometimes it's wrong, but it's OK. So we're going to show you how you can implement this in practice. And by the end of this session, you'll walk away with two key takeaways. First, you'll understand how you can integrate AI capabilities into your device. And second, you're going to learn how to build context-aware AI assistants using multimodal LLMs.
So these are the key technologies that we will be using to build this AI assistant. We're taking a serverless approach for this to handle the back-end processing, and this gives us the scalability and the flexibility we need to be able to manage all of the infrastructure and the demand from the users. It's also particularly useful for resource-constrained devices, for instance, like a Fire TV stick or a wearable device of some sort, because it handles all of that heavy computational loads of working with the large language models. That would be too resource-intensive for the actual device. But the real magic, it happens in the AI components where we're using generative AI through Amazon Bedrock. And that gives us access to a bunch of these different foundation models that we can use.
So for this demo, we're going to use React Native and the Framework Expo, as it lets us build from multiple platforms from a single code base. With React Native, we can access the native device capabilities without having to create separate builds for different operating systems. For example, accessing the camera on iOS, Android, and web requires just one line of code, which is really cool. And we'll see this in action when we implement the camera module of our demo. We want you to know that, yes, we chose React Native, but you can pick whatever stack you like for whatever device you want to target. The concepts will remain completely the same. So let's see how this all comes together in the solution architecture. Starting with the user, they can speak to the device or show it something like we just did through the camera. The device captures these inputs and does some initial processing, like converting the speech to text using the native device capabilities. This processed input then goes to the serverless backend, which handles all the heavy lifting. And the backend is where we manage the conversation context, user preferences, and coordinate with all the different AI services. The multimodal LLMs then do the work of understanding the user's intent, processing different types of inputs all together, like voice and like visual, and generating the appropriate responses.
And this is where that serverless backend really comes into play. It will ensure that we can handle all the varying loads efficiently. So while Bedrock gives us access to the latest foundation models for processing these interactions, but what's particularly powerful is how we maintain context all throughout the entire flow, and we'll show that in detail how that works. But the system will remember previous interactions and user preferences to give a more personalized response. And this is what it looks like in the actual implementation. It's a super simple architecture. We are using a synchronous approach to this. So we're using and building a serverless API that is a synchronous request where we're invoking an AWS Lambda function to then call Bedrock and do that processing with the large language model. We then send a response back to the user. But we're also using Cognito because we want to use security as a first construct in our application. And we're using DynamoDB as a way to store these interactions as well. And Amazon S3, well, that's used for images, for instance.
So from a device perspective, this architecture gives us exactly what we need for those like maybe low-cost devices. Low latency, high reliability, and the ability to handle different types of data. So let's start building. So this is our long to-do list, and don't worry, we will get through it. So let's start with the project setup. As mentioned, our app, we will use the Expo framework. The Expo framework. The docs will walk you through how to get your environment set up. And since, for example, the Amazon Fire devices run on Android, I followed this workflow to install the Android emulator. I set it up with Expo Go, which allows you to develop in that sandbox environment without having to create a development build. And once that's all set up with Android devices, you'll be able to see the emulator running with what comes out of the box with Expo Go in just a few seconds. And what's great about this is Expo has its own router. So when I chose to build my app, I chose to build it with the Expo router, which you'll see in just a second. So we create the app with Expo and the Expo router. And once that's all done, it will build us the project with everything that comes out of the box. And all we then need to do is add in the navigation system to show that to navigate between screens. So let's go ahead and open the template that was created using VS Code. And we're going to build the Android version of this app. So once we open that up, I can't see if my video is playing, sorry. No. OK, it was playing, sorry. There we go. OK, there we go. So we're going to open the template on VS Code and build that Android version using the command npm run Android. And this loads it through Expo using the Android development build. And this app's entry point is the app.tsx file. And once the app has built, Expo Go is going to automatically load it. And in a few seconds, we'll see what comes out of the box. So there we go. Simple app with a few different screens that we're going to go and modify. So let's go ahead and change some of that text so we can see fast refresh working automatically, which is really cool. Change the line of code automatically, you'll see that it's changed on screen. And the nice thing is that it's already set up with the bottom tab, so we have a nice skeleton to work with. Then we've got the navigation and UI foundation. So once again, we have our template. So let's go ahead. Sorry, these videos do not seem to. There we go. Now we have our template. Let's go ahead and modify it for the screens that we need. And I created the extra screen components, like the camera screen, the index screen. And in the index.tsx is where the navigation component is defined. And as of React 71, all the templates are TypeScript by default. So let's go ahead and create the tab param list and the root stack param list to define exactly which parameters each screen can receive during navigation. And by using undefined, we're saying that our screen doesn't necessarily need any parameters. So in the root stack param list, we set it as undefined. We can then define our tabs. So you can see the home tab, the chat tab, and the camera tab. And the camera tab is set up as a modal with a close button. So you'll see this in a second. And the stack navigator manages those screens along with two different screens for profile and not found. And I used React Native Paper for my component library because I really like it. And there's a State of React Native survey, and it's one of the most popular component libraries as of 2024. So to implement it, you simply install it, wrap your app.tsx in the whole paper provider, and you're ready to use those components. So let's see what we've got so far. So we've got those 3 different tabs, the home, chat, and camera, and we can navigate to each one. Profile is a modal, but that's about it. So we're going to start next by creating our API.
All right, so that's a whole lot of front end. So now time for the back end. We're going to start by building the API for us. And, well, back into VS Code, and let's start building it. So I'm going to use AWS SAM, Serverless Application Model, to build this. So I'm running SAM init and creating my initial application. So now with that in place, we can open up our template and open up Infrastructure Composer, which gives us a visual view of the application. I can drag my API gateway into the canvas, just give it a logical name, where I can change the path. Let's call it chat. So now we have the API gateway infrastructure. We can add the next component, which is our Lambda function that will do all of that heavy lifting. In the same way, just give it a name, chat request function. And I'm also going to give it the source path, which is where the code is stored. I'm going to use Node.js 20. There are other options. I prefer Node.js. And then, with those in place, I can connect these two. So now, when my API is called, it's going to invoke that Lambda function. So here we go. This is the Lambda function file that's created. I can open that. You can see just boilerplate code right now. Pasting in the code for my function. In this case, we're just going to echo what we send to the API to begin with. So we send a request to the API. It will echo that back. So that's the initial part of my application. So now we can run a SAM build and then a SAM deploy to be able to deploy my application. I'm going to use Postman to show how this works now. So just get the value for my API, the URL, add that to Postman, and then /chat, and then we can send a message into my API. Hi there, send that. The Lambda function is invoked and just echoing back what we created initially. So now we have the API created. Now, I said security is important. So we're going to add auth to our application. And that's the authentication flow that is both for the back end and then eventually for using that for the front end as well. So back to VS Code. And we're going to use Cognito for this, opening up Infrastructure Composer again. And this is what the architecture looks like right now. I'm going to add some additional components in my lovely YAML. This is the Lambda function. Once again, we're adding an authorizer Lambda function. We're also adding Cognito resources to have a user pool and the policies connected to that. So this is the updated one. It looks a bit more complex, but it's basically an authorizer that makes sure that the request is authorized. We can deploy that as well. In just a sec. That's the authorizer code. And this is also, it looks like a lot of code, but this is basically a standard authorizer that's available as a sample to use. So I don't have to touch it in this case. SAM build, again, and SAM deploy to deploy the new version of our serverless backend. And as soon as this is done, we're able to then test the API again and see that our authorization is in place. There we go. Almost deployed, CloudFormation doing its magic. And back to the API in Postman, we can see now it's unauthorized. So I need to then have a user. I'm going to create a user through the CLI. Just connect to Cognito, create the user, set a password for it, don't copy it. And then I can use that to create my token. The token is what's sent along with the request. So I now generated a token that's working at the moment. I'm going to send that along with the API request, and that's what the front end is going to do later on. So now, when we send the same post request to the API with that ID token, we are now authorized to actually get a response back. So there we go. Now we have a secure backend for your front end, Anisha.
So now in order for our app to connect to those AWS services, we can use AWS Amplify, which provides hooks to easily access AWS services, including Cognito, which we will use to authenticate our app and provide that token to connect to the API. After installing the Amplify dependencies, we will create the Amplify config file. So the Amplify config file is where we set the environment variables, and we'll have to prefix these with Expo public in order to make sure they're accessible in our client-side code since we're using Expo. And we can define these variables in our .env file like normal, as Expo natively supports these environment variables. We then configure our app with the config in the app.tsx. To handle the authentication, I decided to create a React context to implement the Cognito services using AWS Amplify Auth. And I put it in a context because it makes the authentication state and functions available throughout my application. The auth package provides really easy-to-use functions like sign-in, which lets you send the credentials to Cognito, and if successful, automatically stores that JWT token in async storage so users don't have to log in every time to open your app. I then created a new login screen, which allows us to collect the credentials using some of those paper components we saw earlier. And then in my index.tsx file, I decided to create a new auth stack that conditionally shows the login screen if the user is not authenticated to make sure they log in. Finally, I wrap my app.tsx in the auth provider so that all those auth states, the tokens, are available throughout my entire application. So what have we got so far again? Let's see. I can log in. You can email me if you like. And there we go. We're just authenticating our app, and that JWT token is stored asynchronously in our application. Now we want to add voice recognition. So we can start by building our app. The first thing we're going to do is implement the mic from Expo. And we want speech-to-text to happen in real time. So I decided to use this community package Expo module, which has built-in speech recognition for Android and iOS. Now, if your device doesn't have speech recognition, you might want to use a speech-to-text service like AWS Amazon Transcribe. But do note that when you do this, this is going to be an extra API call, and it won't be as real-time as using the native device capabilities. But on low-end devices, this might be a trade-off you may consider. So to implement voice recognition, I first decided to create a microphone component and install the Expo speech module. I used the methods from this module to ask for the mic for permissions, because as we know on device, you have to ask for permissions. And then I started the speech recognition. Once I did that, I created two versions of my mic, because we have two screens which can access the mic with different recording animations. So I could use the same version on my chat screen and create those reusable components. Here, I set values. In the chat context, I then created values for the interim transcription and a variable that tracks whether the recording has finished, so the interim, the final transcription, and a value to track if the recording has finished or not. Then, the microphone is rendered in the home screen along with the box that will show us that transcription when it's being transcribed in real time. Finally, I exported the plugin in my app.json to automatically add those appropriate microphone permissions in my Android manifest, and it would do the same in your iOS version. So again, let's check it out. So now I should be able to talk. And that's all. Just said hello. So now we can speak to our app. The next thing we want to do is have that interface. So since we already created our chat screen and context, implementing it is going to be much, much easier. The first thing we want to do is implement that chat version of the microphone, and this uses the same context, but now we want to show the message. So in the context, I create an array that calls the messages, and once the mic finishes recording, it sets the message in the array in the process transcription function. And since it's all in this context, it doesn't matter where the message comes from, whether it comes from the home screen or the chat screen. It will display the messages in the same way, in one big place. Finally, back in the chat screen, I display the messages just using a simple JavaScript map function. So let's see. Now when I talk, I should be able to see the response.
Who's there?
And there we go. That's our chat interface. Now we're going to go back to the backend and add the data store.
All right, so back into VS Code for the backend now, where it's time to add the data store. So opening up my template file for the infrastructure, I'm now adding a DynamoDB table where we have a user ID and a conversation ID. This is where we can store conversations for each user. So now, using Infrastructure Composer, I can drag the DynamoDB onto my canvas and connect that to my chat request function. That gives the chat request function access to the DynamoDB table. I've split up my code into multiple different parts to make it easier to keep track of. This is where we're keeping track of the actual conversations. So it will store the conversations into our DynamoDB table and then use that as context for the large language model. And we will get information from each request, where we get both the user ID and the conversation ID. And if there isn't an actual conversation ID, we'll create a new one. Building, deploying a new version of the app. And then we can switch back to Postman once again to try this out. So now I'm sending hi there. You can see it's now adding a conversation ID for me. If we go to DynamoDB, we can now check our table and see that, yes, it's actually storing an item that contains the conversation. So if we continue now using that same conversation ID, we're going to store this in the same database item. Hi again, refreshing, and we can check the item. You can see it just keeps adding onto that same conversation. And that is how we store the conversation for the context for the LLM in this case.
So now that we have a storage, we're going to add permissions. Since our response API needs location data, I realized it might be better to move all our permissions into a centralized store too. So first we check whether or not the app has any permissions and if they're already granted or not. So we show a nicer looking permission box if it's not granted using the paper components again. And the permission dialog box is then rendered from the home screen when the app first launches. And it requests both the microphone and location permissions. So now we actually get the location data we can use to actually get the location data, we can use another Expo module, and this uses the get current position async function to get us the position. So again, let's see what that looks like. We make sure that we grant permissions for both the location and the mic. And now we have our location data. Super simple. So now that we've got our permissions, let's go back to handling the LLM.
All right, so the backend so far, it's just doing everything in the Lambda function, just echoing. So now it's time to actually add Bedrock into the mix. So I'm back into my Lambda function, or in the template. I'm now adding the policy to be able to actually use large language models through Bedrock. I'm giving access to all models in this case, because we're going to switch a bit back and forth. I'm going to create a new service within my Lambda function that I call AI service. And it contains some different information that we need to use. We first off have a way to actually create a Bedrock request. We need to be able to create the system prompt that we send to the LLM by adding conversation, preferences, and so on. And then we have the actual processing of the conversation that happens, where we are doing the converse API way of using Bedrock, meaning that we can easily switch between large language models. So we're sending the model ID, the messages, and the conversation to it. Then I'm creating a client. And in that client, we also have constants. And this is where we specify certain things. For instance, the model we're going to use for chat, we're going to use Nova Micro in this case. We have a simple system prompt telling it that it's a friendly AI assistant. And then we have a longer prompt for the actual chat. So the instructions for the large language model, and this is how we control the behavior of our AI assistant. And then followed by the user message when we talk to the AI assistant. So now we're adding that service into our main function. So we can now do the processing of these conversations. We're sending the user input, the device context, like the preferences, and the actual conversation. So with that, we can build and deploy a new version where we're now including a call to Bedrock with the actual chat information. So once that is deployed, we're going to switch back to Postman, making sure we have a token to be able to send a request. Hi, Bedrock. And now we're getting a response from Bedrock instead of just echoing. It created a new conversation, so we can use that ID. And now I can send something else. What's the capital of the Netherlands, for instance? Well, it knows that Amsterdam is the capital, but The Hague is often considered the political capital. That's great. Which one is the best? It depends on what you're looking for. So typical chat with a large language model, fairly friendly based on my prompt as well. And it now also knows context all throughout. So going back to my DynamoDB table, we can see that it's now storing all of this context in each of the conversations for us. That's great. Now?
So now we can actually integrate the API into our application. So we're ready to send the message, and we set up the payload of the message with that final transcription, that unique conversation ID so it can remember the context, and our location data. And we can simply send this via an Axios request. The response then gets appended to the messages array and tagged as an AI response, or the user message, and it gets displayed differently. And I get it to display differently by just having different avatars and different styling. Let's see what that looks like.
Can you tell me a joke?
So now we set up the backend to take in user preferences. Let's get the front end to actually send them. In the context, we had hard-coded those preferences, so we can actually collect that data now. To do this, first we create a preference form to collect the responses. I then set these values in a preference context again so that they're available globally throughout my application. I store these using async storage, which is the persistent storage system that Cognito also uses to save the token. So this is all saved in the same place. And then we can update the context to use the selected preferences that were sent by the user.
There we go. So first, we need to make that possible in the backend. So this is in the context utility that I've created. We are enhancing the system prompt that we're sending to the LLM, and we're then fetching, based on the request, we're fetching location, the time zone, the name of the user, the temperature, what units we want to use. So we're able to use that within our context. And then I obviously need to add that to my AI service, where we're using that context, the enhanced system prompt. So that is what we're actually going to send to the LLM in the end. And then, once we have that, we can now deploy this new version. Here we go. Pasting first a new sample request so we can see what they look like. So once we have all of this context, this is what a request will look like now, where we have the input, the question, or what we're prompting with, but then all of that context with the location, with the date and time, with the preferences, and so on. So now we can use this, copy it, and once again, deploy this new version and try this in our backend using Postman to see how the backend actually handles these preferences and context. So once again, we have a token to be able to send a request, copying that sample request. It says that my name is Gunnar, that the AI is Matthew. Let's just send a hi to begin with. And now it knows, hi Gunnar. So it responds with my name because it has that context. It says that I'm in San Francisco in the context, so I can then ask for things in this. For instance, his name is Matthew. Where am I? And it's going to then look at my location to actually use that. That's cool. So now we're able to use the context from the back-end side. So now it's time for the front end.
So, well, actually, we had some tools we want to first create.
All right, let's add a tool. So when we look at large language models, there's one thing that they are great at. It is knowledge from basically from a few months ago and backwards. They know a lot of things. They don't really know about current events or things that's happening now. So what we can do then is extend that with the help of tools. And tools could be maybe sports results. So you can ask about the latest football game or things like that. So we're going to add a tool, and in this case, we're going to make it easy and use weather, because that's always important. So I'm going to create a new tool that we call weather tool. And this contains information of how to call an API. We're going to use the OpenMeteo API to request information about weather in certain locations. So this function within our AI service is now going to call an API to get information about weather, so we can use that and improve the responses from the large language model. So adding that tool into the constant, so we're able to call the tool. We're then adding information about when to call the tool, when there are specific requests for weather, for instance. So we have the fetch weather data. And here we go, that's the tool parameter. So now my AI assistant backend knows that if there are questions around weather, it should call the API to get weather data back. So once that is in place, we are then able to, once again, deploy a new version that's now using tools. And think of tools as ways to improve the responses with current data of different sorts. So now, once again, we're able to send a request, and I can now start a new conversation. It knows I'm in San Francisco. We can see it's not using the tool right now based on the response. So continuing that conversation, I'm going to ask for the weather today. And now it's going to use the context of San Francisco. It's going to know that it's a weather question, so it's time to use the tool. So tool use true, and then it gives me a response that the temperature is 12 degrees with light westerly winds. So it's now doing that API call in between, which is pretty cool, because that means that we're able to extend how our AI assistant is actually working.
So let's see what this looks like in practice. And because that already sent the preferences along with the payload, we can straight away decide to use it. So let's go ahead and change the preferences.
What's the weather like?
And as you can see, it decided to use the different degrees Celsius versus Fahrenheit. So now that we have our tools and we have our voice, we just want to make sure that we can get our app to be a bit more hands-free. So to do this and add narration of the text context, we can use Amazon's Poly service, which audio streams what we send and uses Expo's audio module to read it out. So I created a hook and I called it Speak. So using this Poly service, we integrate it by installing Poly. And again, you can use Amplify to do this, I think. I'll double check. But once that's done, we install it, we install Expo's AV module, and we create a hook called Speak, which takes in the text context. It then sends it to Poly and temporarily stores the response as a URI, and then plays it back using Expo's audio module. And then finally, in the chat screen, I'll make sure that I call the Speak hook every time a new response comes back, so it speaks. So what does this look like?
Can you tell me the square root of 81?
The square root of 81 is 9.
What about 81 plus 9?
81 plus 9 equals 90.
I do know what 81 plus 9 is, just saying. So the final thing we want to do is add camera, but first we need our backend to have the capability to take in those images.
So back into our backend, we're going to improve the infrastructure by adding a way to store these images. So we're going to add a bucket, use an S3 bucket, add that onto our infrastructure. I'll give it a name. S3 bucket seems logical. Saving that. And now we can then update our AI service, in this case, with a new version, where we're able to then also use images as an input. So we've previously just used text, but now we're creating a separate input that is of image type. So instead of just sending text to our LLM, we're now going to send it the URI to that specific image that's being uploaded and tell it to do something with it. Describe the image, for instance. So there we go. Now we have two different types of prompts we need to send. So we had the chat prompt before that looked like this. So now we're going to add a new prompt that is specifically for images, where we're telling it that the task is to analyze and describe the image. These are the instructions of how to do it, and then provide a certain type of response back. And now we have both the process image analysis and the process chat. So we can now take these image inputs, send them to the large language model, and let's deploy this. What's interesting here, though, is that image processing is different from chat processing when it comes to these large language models. So it's important to use a large language model that can take other type of inputs than just text. So we're going to look at that here. So if I open up my constants, you can see that I now have two different models. Nova Micro for chat and Nova Lite for image analysis, because Micro doesn't have the support to be able to look at images for us and describe those. So now we're continuing this conversation, and now I'm adding an image path to the URI for my image that we've uploaded to S3, as an example in this case, and then just a prompt to describe this image. And it's now going to use the other large language model to describe that image for us. All right, so now the backend supports that for us.
So let's go ahead and get the front end to add that camera integration. So once again, I use another Expo module called Camera Module. Note that this module only works on device. So we can only use it like in our devices. So in the camera screen, first I asked for the camera permissions. And again, I kept this separate to the permissions context to have all that camera functionality in one screen. Using the camera module, I initialized the camera and gave it 3 buttons. One to clear the image, to take the picture, and if the user is happy, toggle the facing. Once the image is taken, a layover will appear, which allows you to either retake that picture or to send it to the chat. It navigates to the chat screen and sends along that local URI image. And this is then added to the message array to appear on the chat screen immediately, but then it's uploaded to S3. So we can use another AWS Amplify service to do that, Amplify storage. And the API is called with the S3 image path once it's actually uploaded to S3. So once there's a response, it's again added to the messages array and shown to the user. But don't forget to ensure that S3 is configured in your Amplify config file. And you'll have to do this with all the different Amplify services. But it's great that it's all in one file. We can put our API there. We can put storage, Cognito, everything in one file. So live demo now. Let's see. What have we built so far?
Stockholm's Parliament building by water at dusk, lights reflecting.
That's cool. What happens in the Parliament building?
The Parliament of Sweden makes laws here. It's a place where serious discussions happen. Think of it as the brain of the country.
Can you tell me a fun law from Sweden?
Sweden has a law about drinking on public transport. It's a bit cheeky, no drinking, but a beer can be a valid lunch.
So I don't know if beer is a valid lunch, maybe. But as you can see, like, it works with both types of input and it remembers the context. And I took this last night, so it was right in telling, no, I didn't ask it about the weather, but I did before and it was cold. So now the final thing to do is improve our prompts.
Yeah, so far the prompts that we've been using have been fairly simple. I think everyone who's ever used generative AI know that the way you prompt a large language model is really everything. There's a reason why prompt engineering is a thing these days. So we've spent a lot of time trying to make these prompts good, to make it a more personal experience. So I'm just going to walk you through a bit what that looks like. So if you remember, we have the constants file that contains our prompts. So we have the system prompt that was super short to begin with just telling it that it's a friendly AI assistant. So we can definitely expand on that quite a bit. So we can give it core guidelines of how to act. We can tell it specifically when to use the weather tool, the capabilities that it has, and what type of response style to be more humorous and personal. For the chat, same way. So we can give it clear instructions of how to respond and what type of responses we're expecting from the AI as well. And same with images as well. So in our case, we have this stored in the contents file. This means we have to do a redeployment to actually do this. My next step when it comes to this would probably be to move those into, for instance, app config, meaning that we can have them as configuration instead, and deploy it that way.
So remember when we started this talk, I told you that using React Native meant we could deploy on Android, iOS, and web. So this is the web version, a website of our app that we built in 40 minutes. I think that's pretty cool. So I think she's British in this video. Oops, sorry. Is it working? Okay, she is British in this video. But basically, it's our app running on the web as well, which I think is really powerful. Like, to have the same app running on both your devices and on the web with, the same backend, it's pretty awesome. And we did that in about 30 minutes. So I will show you this later if you want. I don't know why the video is not playing, but yeah. So the final thing we need to do is a few considerations. So when building this AI assistant device, there's a few things we have to consider, like the edge cases in the user inputs. So your device needs to gracefully handle situations like the partial voice commands, like unclear speech, or unexpected user interactions. And we saw some of these challenges with the speech recognition. Latency is another crucial factor. Users expect like near instant responses, but you're dealing with network calls, AI processing, finding the right balance between those AI network capabilities and the responsive user experience is key. So yes, you may need to make the trade-off between using the native device capabilities or using like an API call to transcribe. Now, the last two things is the resource constraints. So these will obviously influence your design decisions because some devices have limited capacity, processing power, and memory, and you'll need to optimize your AI models and carefully manage those resources. And finally, we saw in our demonstration again that the voice-to-text processing has its own challenges. So you need to decide the trade-off all the time between using the native device capabilities or making those additional API calls. Each approach has its trade-offs in terms of latency, accuracy, and resource usage, but that's up to you. And again, this can work on any device. We just chose React Native and mobile and web as an example, but any device you can use the same logic and concepts.
So you might have seen this slide a few times today already. Check out Skill Builder. Before we wrap things up, I wanted to ask you, Anisha, I mentioned app config as a way to move out those prompts into another service to be able to create those and iterate on them. What are other things you would like to improve on the app?
Yeah, so I think you might have seen, but on the chat screen, you can't actually type. So I want to add a little typing function so I can use it even if I'm on the bus and I don't look silly. And another thing is making the navigation between some of the screens a bit easier, maybe storing the conversation so that you can go back to your conversation. But I think what we've achieved in 30, 40 minutes is pretty cool for now. Yeah. So yeah, we'll be voting on the app for sure.
And a couple of other things I would like to add is we now built it with a synchronous API. I think it would be interesting to try it with asynchronous instead and using WebSockets. So we're sending a text prompt to the backend, and then we're getting it as a WebSocket response back when it's processed. That means we could also do notifications, actually having the backend push things to the front end, to the application. So there are a bunch of stuff we would want to improve, and probably also add video. I think video support would be cool as well. So we'll continue working on it. And I do have a question when it comes to that. So far, we walked you through a bunch of code. I don't think you were able to screenshot all of it. Would anyone be interested in us publishing this as a code sample? I see a bunch of hands, so that's cool. So we will be doing that then. So you can all look through the code and hopefully even help us improve on the application as well. So with that, we want to thank you all for joining us today. I know you've had a long day. Hopefully you've had a fun day. I definitely have, and I hope you enjoy this session as well. Feel free to connect with us on social media. And with that, thank you all very much.
Thank you.